So yeah, while that's going, I'll say, hi, I'm Bart. I'm a Rust guy since soon after 1.0. I'm a professor at Portland State University in Portland, Oregon in the United States. And am very, very excited about embedded Rust. And this is going to be a talk that for some of you may cover very familiar ground. And if so, I apologize. But what I want to do today is talk about where we've come in embedded Rust, where we are, and where we need to go to really realize the full potential of this super cool thing. But before I do that, I want to put my acknowledgments at the beginning. I want to thank a bunch of people. I want to thank the Rust Embedded community. The Rust Embedded working group in particular has been amazing, and I am notionally giving this talk on their behalf, although any stupid thing I say was surely mine. Don't blame them for my talk. But absolutely gave me this opportunity to speak, and I'm very excited and grateful for it. It gave me the opportunity to do a lot of things that I wouldn't have otherwise got to do in the embedded space. I want to thank the Rust Week folks, because this is an amazing event. I want to thank FutureWay for their support, which has funded a lot of my work and has gotten me able again to do things I wouldn't have otherwise, and in particular has allowed me to fund a thing that run a thing that I'm very excited about called Rust Edu, which is a group intended to bring Rust education to academia, but also to industry and other people. If you are interested in that, I highly encourage you to check out our Zulip, our website and our Zulip, and get involved. It would be fantastic to have you. So having said all that, I want to go ahead and really hit... Oh, sorry. Apparently I don't know how to operate a slide anymore. Let me try that again. I want to hit... The Rust Evangelism Strike Force returns. I don't know how many of you remember this meme from olden times, but I feel like it's time to revive it. And in particular, I feel like it's time to revive it on behalf of the embedded squad, the group that are doing the embedded thing. I think that's where the action is and where the action is going to be in a lot of ways for the near future of Rust. And that's the case I'm going to try to make to you today. So, before we talk about what we're doing in embedded, we have to have the argument you always have every time there's embedded, and it's really frustrating, which is, what do you mean embedded? What is this embedded thing you're talking about? And it's really, really fuzzy. I want to be super clear. I tend to use the famous Justice Potter definition of I know it when I see it, but that's obviously pretty unsatisfying. That computer on the lower left corner is my first computer, the Northwest Microcomputer Systems 85P. It had dual 8-inch floppy drives and 64K total between RAM and ROM. It was a 8-bit processor, and by the standards of the day, it was an awesome desktop computer. Now, of course, it's a tiny embedded device. The Kim 1 there in the middle is another one of these computers that I worked with in the early days, in the late 70s, that was a little 6502 with like a couple of K of RAM and no flash, it wasn't flash yet, no ROM. It was, a fantastic little embedded board. And then on the right is the Milk 5 Duo, which is a $5 board that has plenty of memory for running Linux and a TPU sitting on it. Is that an embedded board? I don't know. We typically talk about embedded being, sort of very small form factor, whatever that means, so that it can fit places. We talk about it having limited resources, although these days not that limited. We talk about it being programmed, and this is, I think, the important thing, using bare metal code, which is, of course, one of those cool sounding things, but all it means is that I control, or can in principle control, every byte that sits on the computer. There's no operating system in the way. There's no, layers that aren't there because I put them there. And that's kind of cool. And they typically either run in that we typically write either bare metal embedded, or we write real-time operating system embedded. There's a whole interaction between real-time and embedded that we won't get into here. And so I'm driving things pretty low, and typically what I'm driving partly is pins, right? The wires that come right out of the chips and that I can use to connect to things in the most bespoke way possible instead of having standard connectors or interfaces. They're sort of standards, but they're very low level. And so, why is it that we're doing Rust, right? We got to remind ourselves sometimes. And I think this is, to me, an important part of the message for today is that, we get obsessed with memory safety. Rust is the memory safe language. Well, yeah, it's the memory safe language, and that's super, super cool. Without a garbage collector, we can avoid all the footguns of memory systems. But, garbage collectors are nice too. And also, yeah, that isn't the thing, right? If it was just like some other language, but with a borrow checker, I would be a lot less excited. I listed a bunch of things that I thought of off the top of my head that Rust is, that other languages typically aren't, all of, or even a lot of. And it's a long list, right? Our type system is, certainly beyond, closer to the state of the art than most type systems of languages that are in common use today. Sure, we're not Haskell, but we are a thing. We have super nice modularity and composability. We take for granted a really solid module system, good notions of private and public, the ability to compose modules and then compose those modules into crates in a clean way. You shouldn't take it for granted. It's an important part of what makes Rust cool. We have a build system that is absolutely 100% civilized, right? It's a build system that's bespoke for Rust, but that we can use in flexible ways when building Rust things. It's got a crazy amount of cross-platform capability, which is super important for embedded. It is just, we love our cargo and stuff, and we should, because it's really important. We have, very convenient public package store, right? Crates.io is amazing. And the fact that I can go just grab stuff off a Crate store and the build system will do it for us and just make things work. How cool is that? We have a stupidly good backward compatibility story, right? We really do have the experience. I really do have the experience of taking code I wrote 7 or 8 years ago and just compiling it and running it again without any issues, concerns. That's kind of special. It's really kind of special. We have, absolutely crazily good versions of integrated tools. Rust, other languages obviously have formatters. They obviously have, dot comment tools. They obviously have linters. But ours are good. I mean, they're like really, really good. And the fact that in particular that we use our formatter and that everybody's agreed on the format of the language, whether they like it or not, that's kind of special if you're working in some other language community. And we have nice levels of support for compile time checking of parallelism and concurrency, right? We have great threads, but we also have async await, but we also have send sync and all this stuff that checks that your thing's going to be right? No data races in safe Rust. How cool is that? We have an FFI that works really, really well in general for interoperating with other languages. And I could just keep going, right? You're all bored now because you're like, yeah, we knew all these things. But look at them collectively, right? Look at what we've built. And yes, the memory safety is great, but this other stuff's great. And, I always think of that, line from the life of Brian. Yeah, but what other than that, what have the Romans ever done for us, right? I mean, it's an amazing ecosystem. And so the story we need to tell in a lot of domains is, there's a lot here, and you want all of it. But what about embedded specifically? Because this is supposed to be embedded talk. What I'm going to argue is that this is where we're the most special of anything. Right now, I'm teaching Rust Web full stack, and I'm teaching Rust embedded at my institution. And they're both great fun, and they're both cool. And I would absolutely recommend Rust as the language of choice for writing web applications, just like I would recommend it as the language of choice for writing embedded code. But the difference is that for web apps, there are some other stories, right? It's not crazy to want to write your web app in Go. It's not crazy to want to write your web app in JavaScript, I guess, TypeScript. But for embedded, we don't have a lot of great choices out there, right? We have certain legacy languages, let's call them, right? I want to be polite about this. I'm sure there's some C++ people in the room, and we love you. Absolutely, we're not trying to diss your universe, but I have to say, right? We have to say out loud, I think, sometimes a little bit that Rust has an amazing story for embedded that's just unparalleled compared to the story that's offered by the alternatives. And that's the word we've got to get out there. And right now, I think people aren't hearing as much as they could and not understanding the full story in what they hear. Let's talk about where we've come, though, because, it's only been 10 years. And in that short amount of time, we've done some really, really, really cool things in the embedded space, right? 8 years ago or more. These dates I grubbed off the internet, and I hope they're roughly right. People can correct me later. I make mistakes. But roughly 8 years ago, this thing that was then called Real-Time for the Masses, and now is called Arctic, was put in place as a Rust embedded framework for writing embedded applications, and it was fantastic. About 7 years ago, the Rust Embedded Working Group was formed and made part of the nursery, the Rust language nursery. Jose Aparicio and those people did some amazing, amazing work in sort of starting to standardize what Rust embedded would look like in ways that were really, really powerful in terms of getting things going. And that was, it was a long time ago, and yet it was only yesterday. It was about 7 years ago, I think, that Ferris Systems was founded, which is a very, very important player in the Rust embedded ecosystem. I'll have more to say about them later. And in particular, their release of Ferrocene, a almost complete subset of Rust that's been certified to the highest ISO safety levels so you can use it in stuff like cars, is pretty cool and pretty necessary to what we're doing. And Embassy, it's hard to put a start date on it, but the first official release was really only, the full release was really only a year or two ago. And that is an amazing, another runtime system that takes advantage of async await to enable a really, really nice style of writing Rust embedded code. So we're moving fast. We're not moving recklessly fast, but we are moving fast and in a really, really positive direction. Compared to 2 years ago, there's way more options available, and they're way stronger and better. And I think that's part of the story we have to get out there too, is that if you looked at Rust embedded a long time ago, you should look again for sure, because there's some super cool stuff that's new. But having said all that, I'm old enough and was involved with the X Windows system enough to remember when it was frequently declared the year of the Linux desktop back in the 90s, mid to late 90s. I had a hard time pinning down the original source of that quote, but I promise you it was everywhere. And it was a sad story, right? Because every year was going to be the year of the Linux desktop, and then it never really was. I'm presenting these slides on a Linux desktop. It isn't like it's gone away, but the market share is not anything like 100% or even like 10% right now. And we could be there too. There was a nice quote on the Embassy blog that clearly 2024 will be the year of Rust on embedded. And I was excited, and I hope that, but on the other hand, I've been here before. So we really, really, really have to understand that success is not inevitable. It takes vision, which so far we seem to have in abundance. It takes hard work, and a small number of people are putting in a lot of hard work on this stuff, and I would love to grow that pool. And it takes some luck, and never underestimate the power of luck. But what I want to do today is encourage you to think about how we can make sure that this comes true, because like I say, it's a necessity. How do we move forward? I'm going to have some boring slides without many pictures on them for a while. I apologize. But I really want to talk about what we can do in the education in education to on-ramp people into the embedded ecosystem. Hopefully some of the people in this room on-ramp them into the embedded ecosystem. I want to talk about how we can advertise, how we can get our message out better of what embedded Rust has to offer. I want to talk about how we cover more of the space. We're already doing pretty good, but there's more we might need to do. How do we get stuff usable and then get it used, right? That's a question that I think is really important. And I want to talk about the organizational aspects. You know, we've got as far as we have by having good organization and teamwork. And I think we need to even more as we go forward, have good organization and teamwork. So let's just take these point by point a little bit. Obviously, as the representative of RustEdu, I am excited about the educational aspects. One of the things I've been doing for the last year or so is editing the Rust embedded discovery book for the Microbit 2, which is, I think, a really, really good on-ramp resource for checking out embedded Rust. And we're trying to make it better as we go. There's a lot of materials in the ecosystem that have aged. There's a lot of places where any one of you could jump in, learn a tiny bit, take on some writing, and really, really help out. And I think that's going to be really, really important, is bringing stuff up to date so that it all looks new and fresh. The course content is a thing. That's something I'm supposed to be doing, and I'm making some good progress on. We really need to we have some pieces out there. The comprehensive Rust short course on embedded is amazing. TeachRS has some modules on it. The Ferris Systems training materials, which they're gracious enough to open, are awesome, and I can highly recommend them. There's a bunch of tutorials and books, some of them commercial, some of them open, that you can get access to. But what we really need to do is figure out sort of how we get that into a coherent single piece. That's kind of RustEdu's job that I would love to have you come over to RustEdu and help me with, so that we have a single product to deliver that makes sense. There's a lot of advanced, pro training and embedded for industry, but the path to get advanced embedded topics by self-teaching is a little rougher. The good news is that the Embedded Rust working group Matrix and the related Matrix stuff on Matrix are places where you can go ask for help. We do absolutely have good contact and one-on-one, but we need to get more written materials and help this thing scale. We have a surprisingly good coverage in Rust. Almost whatever processor and whatever board you bring along, we probably can mostly already support it with out-of-the-box Rust without you having to do too much. That's an amazing story, because the world of embedded systems, unlike the world of big computer systems, is super diverse in terms of the range of hardware that's out there. And I'm not claiming we covered all of it, but Cortex-M systems, for example, ARM is a microprocessor standard, right, for those of you who don't know, and there are sort of three kinds of ARM parts. There's the A parts, which are intended for cell phones and stuff like that. They're real full computers and barely embedded devices. The R parts, which are very little known and are intended for applications like brake controllers, heavy industry stuff with concurrency and reliability constraints. And then there's the M parts, which is what every hobbyist is using. They're amazingly cool little microcontrollers, and those we've got pretty much. The R parts is newly active. Jonathan Pallant and others at Ferris Systems have demonstrated running Rust on a Cortex-R part, and that's an exciting milestone for us, because combine that with Ferrocene, and you've now got access to a bunch of markets that are really going to be important. Our RISC-V story is pretty good. I first started doing embedded Rust on a RISC-V board 5, 6, 7 years ago, something like that, and it was fine then, and it's even more fine now, no surprise. You may have heard a lot about the ESP32 Espressif systems, and the ESP32Cs are a RISC-V part. The 32Ss run their Extensa custom ISA, and Espressif has supported are the first vendor to offer official Rust support. They are funding and supporting the development of the Rust compiler backend that supports the Espressif parts, and that is super, super cool. AVR, the thing that the Arduino runs on, the @mega parts, that's working okay, I think. I've never tried that, but I've heard good things from people who have tried it. So we've got the space pretty well covered. One of the things that makes ARM easy and special and cool is that you can use something called system view descriptions, which are XML provided by the processor manufacturer to auto-generate Rust crates to support a particular processor. That's kind of cool, and we're doing a lot of that kind of stuff. We absolutely have the embedded HAL traits, which are crates that provide trait definitions for traits that you can use to write portable device code for your thing. That's been really, really super important. We really are heap optional. Honestly, if you have enough RAM for a comfortable heap, you probably are barely embedded, but maybe you do. In that case, you can use it. You still probably don't want to use the standard library because it's so big and so, sort of not fit for purpose. But you absolutely can get by without any heap, and we have good support for that. Or you can get by with a limited heap, and we have good support for that. I'm going to speed through a little because we're running toward the end here. I think uptake is a place where, in the motto of the Research Institute my wife used to work at, more research is needed. That was their unofficial slogan. And I think we need to figure out, we need to provide attractive low entry cost frameworks, and we've done that to some extent. We've got Arctic, which is amazing. We've got Embassy, which is amazing. We've got the Talk as an example, one of several examples of a real-time operating system written in pure Rust. We've got Rust bindings for other operating systems now. Things like Zephyr provide Rust bindings if you want to use those as your real-time operating system. So we have a good story there. We need to provide better hobbyist entry points. The MakePad people are here as usual and are doing something that's really cool. What we really need is to have an answer to the Arduino thing, which is what the C++ people use in, as a sort of an on-ramp for hobby developers who might start out as hardware people with little programming. I think we can do better, and I think we're starting to do better. We have the professional entry points. One of the things where we really don't shine, and we need a lot of help, is we don't measure as well as we could. If we need to spend more effort on understanding who's using our stuff and who's not using our stuff and why the people who are not using our stuff are using our stuff. And I think that's a thing we can improve going forward. Organizationally, like I say, I don't have enough good things to say about the Rust Embedded Working Group. Now, maybe that's self-serving because I'm sort of officially part of the Rust Embedded Working Group, but I think they're amazing people and the leadership there is cool. We have lots of institutional support. A bunch of different groups have stepped up and really helped, not just with funding, but also with organization. One of the things that's happening this week as we speak is that our relationship with the Rust Project and the Rust Foundation is somewhat in flux. People are trying to decide how that fits together going forward. And so I would really encourage people in this room to think carefully about it and then advocate for what you want to see happen, because it's going to happen soon and make a difference. Why am I so urgent about this? Well, part of the reason is that I think this is where the stable Rust jobs are going to be to some extent in the future, the ones that are reliably there. AI is, and plus, the new round of offshoring from traditional software producing countries to less traditional ones is happening really fast right now. And a lot of jobs, even jobs that would potentially be Rust jobs, are going away or moving. The embedded world tends to be stable in that regard. It's a place where we can kind of promise you a big opportunity if you learn this combination of hardware and Rust skills. But also, obviously, security and reliability has got huge attention in the embedded systems and Internet of Things spaces. Things have gotten a little grim. I chose to highlight this bug. I'm not picking on anybody, but it was such a great demo a couple weeks ago. Wormable zero-click remote code execution in AirPlay protocol. What that means, in case you're not familiar with the lingo, is if a bad guy happens to get too close to your Apple IoT device, that's running AirPlay with their radio, then they can run whatever code they want on your IoT device. Whoa. And so you think, well, yeah, but everybody's always saying blah, blah, Rust, blah, blah. Would Rust have really solved this? Look, there were 2 CVEs here, one that reported by Oligo. One reported a buffer overflow on the stack, and the other one reported a use after free. So yes, Rust would definitely have solved those, right? I mean, it's not a case where it's ambiguous. The current mitigation is you turn off AirPlay and hope. Last I heard, maybe Apple's got a fix out by now for their host machines, for their Macs, but updating embedded IoT code is a nightmare. And I reckon there's still bajillions of IoT devices that are vulnerable to this attack and will be for the future. We need to do better. So here's what I'm asking you to do. I know, I chose this aesthetic on purpose. I hope folks will forgive me later. I need you to check out what's going on. If you're not familiar, check us out. It's really cool, and we're really friendly, and we would love to have you become part of our thing. Even better, if you feel like helping out in Rust in some way, I know most of the people in this room are up to their neck in helping out in Rust, but if you're not and are looking for a place to help out, help us. I promise you we have projects at every level where we can use your help and support. It's not hard for us to find that. Do support us with the Rust Project and Foundation. Make sure that, if you're part of that, and some of you in here are today, understand this is a place where we need attention. And if you're not, encourage people to think about that. But of course, the most important thing, which is what I've been trying to tell you, is to spread the word. Just get the word out there about Rust Embedded. I think it's really part of our future, and I'm really excited to see it go. So that is what I have for you today. I've left some time for questions, but I also will be around for the rest of the week. So bug me now or bug me then.
If you have any questions, could you please come to the front of the room? Hello, Strike Force member, reporting for duty. You mentioned...
Oh, no. There we go.
You mentioned the hobbyist path into this whole ecosystem, and you mentioned a professional path into this ecosystem. But I work at a small C shop that is neither hobbyists, nor are they going to shell out for Ferrocene or anything of that ilk. Do you think there's
It's kind of free.
Oh, it is?
Well, I mean, it's open source. Yeah.
But do you think there's a recommended or more viable path for getting a small C shop like that to take Rust seriously as an option and not just think it's overcomplicated? Or do you think it has to come from those other ends of the market first?
No, I think so the thing about embedded is that, yeah, there's a continuum, and I was pointing at the ends of the continuum, and you're right to call me out for that, but we understand there's everything in between. One of the places where we do need help, though, is that our materials for on-ramping people at your spot in the ecosystem are not as good as for beginners. And, for experts, we have professional, for people who want to work at industry scale, we have professional training that you can buy from various places, and that works great. For beginners, we have the Rust Embedded book that I'm working on that is the discovery book's pretty good, and I would highly recommend it. For people in the middle, we don't have as good of educational resources, but honestly, what I've found teaching this over and over again to college students is that you don't need that much Rust to get started, and you don't need that much embedded to get started. It's one of those things where just, the thing that you have to convince, I think, companies in your space to do is to give it a fair try. And that means having somebody who is either knows or is willing to learn a little bit of Rust, either knows or is willing to learn a little bit of Rust embedded, and sort of prototype and mess around, and has, I know that's a big ask for a small company, but be willing to prototype, mess around, see what works for them and what doesn't. My experience has been that people who stick with it a month, and this is one of those things that's easy to say, but people who stick with it a month will stick with it for a long time. That's about how long it takes to get super excited if you're poking at it for a while. So that's, I guess, my best answer. But yes, come help us. Come help us make it better for you folks.
Okay, thank you.
So I've done a bunch of hobby projects on Cortex M Blue Pill board.
Oh yeah, those things are
Yes.
cool.
Yeah. I also have some of those Milk 5 duos, but I haven't used them for anything yet because the Blue Pill is more familiar to me.
Me too.
But the way I am doing things is the same way that I've been doing things when I first learned Rust embedded a few years ago, which is using the HAL crits. And something that I found is that because it uses the type system for safety to make sure you have safe access to the registers and peripherals and things like that, you end up with these really unwieldy types that have lots of generics in them. And as soon as you can no longer rely on type inference, like if you want to make a struct or a function, you're not just doing everything in main. You have to write out all those types yourself, and it gets really frustrating. So I wanted to ask if there's any developments in the ergonomics of this kind of stuff to make it easier for us to write this code without getting frustrated with really complicated types and complicated errors and things like that.
Yeah, I mean, you're absolutely right that people get frustrated with that. One of the things I'm guessing you found is that you've gotten used to it over time, that it was much, much harder in the beginning than it is now to deal with that. But it sounds like you're still having pain with it. It's always easier, I think, to provide safety and then provide escape hatches to get rid of it than it is to start without any safety and then try to provide escape hatches to add it. And that's been the approach of the embedded traits. So as you know, I think, you can always degrade, for example, a pin type into a generic pin type. And that is often the right answer, right? If you want or need that type safety, you've got it. But if you don't have it, just make it go away, right? And that is absolutely possible to do in the current space, and that's what I would encourage people like you who are still struggling with the type system to use. For those of you who don't know, there's this thing which is really cool but really frustrating in the Rust embedded space, where every pin on a microprocessor is given its own type. Literally, it's a unique type for that piece of wire. And you think that's the craziest thing ever. Why would you ever do that? Well, for example, that means that if I try to, there's traits that say, the ADC can only be connected to these pins. And if I try to connect it to the wrong pin, I'll get a compile time error instead of a runtime thing that takes me 10 hours to debug. It's super useful, it's super safe, and it's super frustrating because these types get insane.
It's more that the Rust language, because it only has type inference for local variables, and if you want to refactor the code, and you have to figure out what type that was and type it manually.
Yeah, the biggest problem is that Rust's situation with globals is awkward, I think. And that's the place where you end up having to describe these types because you don't have a choice. And even if it's a degraded type, it may be fancy. So I think the answer is no. I don't have any great things to support. If you look at how the crates use these types these days, I think it's better than it used to be. But there's a lot of work to be done there. It's absolutely an area that good ideas would be welcome, I think. It's the best I got for you.
So there is tons of firmware for, the application processors, just for bringing them up and such. How do you feel about Rust embedded in that space, like Cortex-A and such?
Oh, I don't know the Cortex-A story very well. I probably shouldn't speak. I know that one of the things we just did in the Rust Embedded Working Group was combined the Cortex-A, Cortex-M, and Cortex-R groups into a single ARM group. and I think that's a really good thing, I think, because what it means is that we'll have a lot more crosstalk between people like me who don't understand A at all and, the people who do. But I think Rust works really good there, but I think the story is less interesting in some ways than it is for the M parts because the A parts really are just, computers. they aren't. There's not that much that's weird about them, right? You've got virtual memory and giant RAM address spaces, and it's like, oh, okay.
Well, you need to get there first. And, we've been running a project for doing that for about 5 years now, using the embedded Rust traits, actually.
Cool.
And that includes the Milk 5 Duo, if anyone is
Oh, that's super cool.
Yeah.
I want to see your project. Drop me stuff afterwards.
Right. I'm sitting right there. In a
Perfect.
bit again.
So you mentioned how ferrocene enables the use of rust in the automotive industry, but is there any work regarding certification for the aerospace industry? Because I imagine that'd be quite a bit more complex.
It is absolutely an active topic. I'm not directly involved in it, so I can't speak for the people who are, but I know that there is a group of people who are trying to get some of the aerospace certs right now as well. And I think the work, the ISO cert that they got for ferrocene will make that a lot easier because a lot of the conditions and processes are similar. But yes, it is definitely ongoing and definitely a priority for people.
All right, that sounds good.
Yeah.
Thanks.
Any last questions?
Thank you very, very much, Bart,
Thank
for the
you. That
fascinating
was
talk
fun.
and the whirlwind tour of Rust Embedded.